Bismillah ar-Rahman ar-Rahim. Now we're going to continue our explanation of dynamics, differentiation of vector functions. Now we're going to study the curves. Okay, as we studied before, we have different vectors relating to the collinear motion of any body moving in a straight line. Okay, we have the displacement S, displacement vector, and we have velocity vector. Okay, we have also acceleration vector. Okay, as we said, we have S equals R of t minus R of 0. We have also velocity equals first derivative of the displacement with respect to time, ds dt. Okay, also have acceleration equals dv dt, or second derivative d2s dt square. Okay, now we're going to explain different types of curves relating to each of these vectors with time. Okay, we'll start with the curve expressing the relation between displacement and time. Okay, and this curve is called ST curve. Okay, if we have this curve relating expressing the relation between S and time for a body moving in a straight line. Okay, here from this curve, if we have this curve representing the motion of, or the displacement of this motion. Okay, here we can find the displacement first. Displacement in this from this curve is if the curve of this motion lies above x-axis or time axis, then displacement is positive value. And if we have here, for example, the curve moving according to the body moving according to this curve, which lies below the x-axis, okay, then s is negative value. Okay, then s is positive when curve lies above x-axis. Okay, and it's clear that x-axis represented by time. Okay, s displacement is negative value when the curve of st, okay, lies below x-axis. Okay, this is first point. So from this ST curve, we identified the sign of the displacement of the motion of this body. Now we can find the velocity of the body at any time. For example, t. If we assume this one as t1, okay, to find the velocity of the body at t equals t1, we can find the slope of or the tangent to the line at this point t equals t1, and find the slope of this tangent. The slope of this tangent can be represented by the tangent of the angle made by this tangent with the positive direction of x-axis. This angle is theta. If theta is as we said obtuse as in our example, then the tangent of theta is negative, and consequently we have the slope of the tangent, okay, is negative as well. Then velocity here is negative value. Okay, and if we assume, for example, this point at t equals t2, and we made this or draw or sketch this line representing the tangent to the curve at t equals t2, then we have here theta2. Theta2 is acute, then the tangent slope of the tangent is positive. Then here the velocity at t equals t2, velocity at t equals t2 is positive value. Okay, now from this curve we identify the sign of a displacement, and also we identify the sign of velocity velocity as we explained before. Also have to say that if velocity is positive value, it says that the body moves in a forward direction. Okay, but if velocity is negative value, then the body is moving in backward direction. Okay, backward direction. Now we'll explain how to find the acceleration from this curve, displacement and time. Okay, curve is time curve. How to find acceleration? Okay, if we have this curve, for example, this form, okay, representing the displacement of a body moving in a straight line with respect to time, then to find the sign of acceleration A, okay, if the curve during this, for example, time interval, if we have here t1, t2, t3, during t1 to t2, okay, this open interval, okay, here the curve is convex upwards like this, okay, then acceleration is negative value. Okay, then acceleration is negative when we have upwards, okay, convex curve, okay, as the curve in this time interval t1 and t2. Okay, if we have t2 and t3, and during this time interval we have the curve here downwards convex, okay, then acceleration is positive if the curve is downwards convex. Okay, as during this time interval t2 and t3, and always we use open interval as we showed during explanation. Okay, this is a method how we can find the sign of acceleration of the motion of a body moving in a straight line if we have the displacement time curve relating to this motion. Okay, now we'll move to the curve relating the relation or expressing the relation between the velocity and time. Okay, and this curve is called VT curve. Okay, here if we have this curve representing the relation between velocity of a body moving in a straight line and time, okay, and we have this form, for example, okay, as we explained before, if the curve is above x-axis, then velocity is positive value. Okay, and if the curve is below x-axis, okay, or time axis, then velocity is a negative value. Okay, if the velocity is positive value, then the body moves in forward direction, and v is negative when the body moves in backward direction. Okay, this is first one. Second point, we can find the sign of acceleration of the motion of this body from this curve. As we have acceleration equals dv dt, then this represented the slope of the tangent to the curve at any time t1, for example. Okay, if we have this time, for example, this point or this moment t1, to find the acceleration of the motion of this body at this time, at this moment, we can draw this tangent to the curve from here to this t1 at t1 moment, and we check the angle here made by this tangent with the positive direction of x axis. This angle theta is acute, then slope of this tangent is positive, and consequently acceleration a is positive as well. Okay, and if, for example, we find here this t, for example, this t, okay, and we made this tangent, okay, and here we draw this horizontal axis parallel to x-axis. Here we find this theta, okay. Theta is obtuse in this example. Then we have here at t equal t2, for example, or t dash, okay. Here the slope is negative and acceleration is negative at t equals t2 or t dash at this moment, okay. Acceleration is negative, okay. As we know, the slope of the tangent to the curve of vt curve at any moment represents the acceleration of the motion of this body at this time moment, okay. And as we know, acceleration equals dv dt, okay. So up till now we used vt curve to find the sign of velocity, positive or negative, and decide which direction the motion moves in, okay, forward or reverse. Forward direction if the velocity is positive. If the velocity is negative, then the motion is in backward direction. Also from this vt curve we identified the sign of acceleration during any open interval, okay, by deciding the slope of the slope of the tangent to this curve representing vt relation at any moment. If the slope is positive, then acceleration is positive, and of course if the slope is negative, then the acceleration is negative as well. Now we're going to explain how to identify the type of motion of a body moves in a straight line. Type of motion means you have to decide or identify if the motion is in forward direction or in backward direction, or the motion is accelerating or decelerating, okay. We have to check first velocity v. If velocity of the motion of this body is positive, then the body moves in forward direction, okay. If the velocity is negative, then the motion is in backward direction, okay. Okay, secondly, we have to check v times a, velocity of the motion times acceleration of the motion, okay. And we check the sign of this multiplication, okay. If this value is positive, then the motion is accelerating motion, okay. If this is negative, then we have decelerating motion, okay. Then if we have an equation representing the motion of a body or a curve representing this motion of this body, we have to find first the sign of velocity during or within any open interval, for example t1 and t2, okay. And you check the sign of this velocity during this time interval, if it's positive or negative. If it's positive, then the motion is in forward direction. If it's negative, then the motion in backward direction. And then you have to find the sign of acceleration as well and multiply v and a. If v and a is a positive value, then the motion is accelerating, and if it's negative, then the motion is decelerating. Now we'll explain how to identify types of motion during a certain time interval, open interval t1, t2, when it's a given displacement time curve, okay. The curve representing the relation between displacement and the time of a moving body which moves in a straight line, okay. As we said, first we have to identify the sign of velocity, okay, and acceleration within this time interval t1 and t2 according to the explanation before, okay. First, for this curve you have to take care that the x and y axis, here we have displacement and time curve, okay. Velocity here is the tangent of this curve at any moment between t1 and t2, and it's clear that if you draw this tangent, okay, then the angle made by this tangent with positive x-axis is obtuse. Then we have here v is negative in this case, okay, then the motion is in backward direction, okay, backward direction. This first one, okay. Second, we have to identify the sign of acceleration, as we have also ST curve. Then the curve is downwards convex. Then we have acceleration here is positive. Acceleration is positive, as we have here downwards, okay, convex curve, okay. Then here from this sign of the velocity, we identify the direction of motion is in backward. Then we have to multiply v and a. Here we have negative times positive value, then we have negative value. Then the motion is decelerating, okay, in backwards direction, okay. This is relating to this case, okay. We can apply these rules for this curve. Here we have ST curve as well. We have T1, T2, this open time interval. To find the sign of velocity, we can check the slope of the tangent at any moment included between T1 and T2, and we can draw here this horizontal axis parallel to x-axis. Here we have this theta is acute, the slope is positive, and we have v here is positive, then motion is in forward direction, okay. For acceleration, here the curve is upward convex like this, and acceleration is negative here. And here we have upwards, okay, convex curve. Then we have here acceleration is negative. Now we can multiply VA. We have positive times negative, then we have negative. Then motion of the body is decelerating, also decelerating, but in forward direction. Now we can apply the same steps or rules for this curve. We have ST curve. We have S here is constant, okay. Then we have velocity equal 0, as velocity is ds dt, and this is equal 0, and acceleration equal 0, as s equals dv dt, and this is equal 0. Then we have here the body moves in v speed or velocity, okay, v velocity equals 0, and acceleration is 0 as well. Then the body is stopped or not moving, okay, as velocity is 0 and acceleration is 0 as well. For this curve, we have ST curve. We have this time interval t1, t2. During this time interval, we have velocity. Here we can find the velocity by checking the slope of the tangent at any point here. Here theta is acute, okay. Then here velocity is positive during this time interval t1, t2. Then motion is in forward direction, okay. We have to check the sign of acceleration. Here ST curve. Then we have to check the convexity of this curve. We have down convex curve. Then we have acceleration is positive, okay. Here as we have downwards, okay, convex curve, okay. Then acceleration is positive. To find the acceleration or deceleration motion, then we have of motion, we have to multiply v times a. We have here positive quantity times positive, then we'll find the result is positive. Then we have here the body is moving in forward direction according to the sign of velocity, forward, okay, and the motion is accelerating as well according to the sign of VA. Now we have to study this another ST set of curves. We have this one here. We have to find the velocity. Velocity is the tangent of the slope at any moment between t1 and t2. Here, for example, at t here t dash, for example, here we can draw this tangent here. Then we have this angle is obtuse, then v is negative. Okay, then we have backwards motion. Okay, for acceleration here, the curve is upwards convex, then the acceleration is negative. If we have upwards, okay, convex curve, okay, then we can multiply v and a. We have negative times negative leads to positive value, then the motion is accelerating, okay, in backward direction. Okay, we'll apply the same rules here. We have st curve. In this case, we have acceleration. Okay, we have first the velocity is positive. Okay, as during t1 between any at any moment between t1 and t2, we can find the slope of this curve. Okay, here the slope is positive, then then velocity is positive, then we have here forward motion. Okay, for acceleration here, acceleration equals 0 as velocity is constant, then a equals dv dt equals 0. Then in this case we have va equals 0, and the body moves in forward direction according to the sign of the velocity, but with constant or uniform velocity. Okay, we can apply the same rules for this curve. Also, we have here v is a negative value as the slope of the tangent of this curve. The slope of this straight line at any moment between t1 and t2 is negative. Then we have here backwards direction. Okay, for motion, we have a acceleration here also equals 0 as dv dt equals 0 as v is constant. Okay, then the body moves in backwards direction, okay, with a uniform or constant velocity. Okay, this is relating to this case. We have also these two cases. For this one, we have here between t1 and t2, the slope of this curve is positive. Okay, as theta is acute, then velocity is positive, then motion is forward. Okay, for acceleration here, the acceleration here equals 0, then the body moves in forward direction with uniform or constant velocity. Okay, as here we have this straight line. Also for this curve, we have also between t1 and t2, the velocity here is negative as the slope of this curve is negative. This angle is obtuse, then we have backwards direction. Okay, for acceleration here equals 0 as v is constant, in first derivative of v with respect to t is 0, is represented by this acceleration. Then the motion here is in backwards direction with constant or uniform velocity. Now we are going to apply the same rules to identify the type of the motion of a body moving in a straight line if it's a given velocity time curve. In this case here we have to identify the sign of v. Okay, v here is a positive if the curve is above x-axis and negative if the curve is below x-axis. Okay, the tangent of this curve at any point represents the acceleration of the body motion at this moment. Okay, in this case here we have v, the curve is above x-axis and velocity is positive, then we have forward motion. Okay, for acceleration here, if we find the slope of the tangent here at this instant, for example between t1 and t2, here we have acute angle here, then acceleration here is positive, then by multiplying v and a we find plus multiplied by plus, then we have plus result. Then here the body moves in forward direction according to the velocity sign, and the motion is accelerating according to va sign. Okay, we'll apply the same rules here also. Here we have velocity is positive as the curve is above x-axis, then the motion is in forward direction. Okay, acceleration here, if we take any, for example, this curve, okay, this tangent to this curve, here the angle is theta and this is acute, then we have also here positive acceleration, then E is positive, then we have also V A is positive value, then the motion is accelerating also, okay, in forward direction. Okay, forward according to the sign of V, as the curve is above x-axis, and the slope of this curve at any point between t1 and t2 is positive, then acceleration is positive, then V times A is positive, then we have accelerating forward or forward accelerating motion. Okay, here for this curve we have here v is constant, okay, then acceleration equals dv dt equals 0. Okay, v is constant and positive value as the curve is above x-axis. Okay, then we have the motion is in forward direction, okay, with constant or regular or uniform velocity. Okay, for this curve here we have velocity equals 0, then acceleration equals 0 as well, and va equals 0. From this value v equals 0, we can identify that or decide that the body is stopped, okay, or not moving, as velocity equals 0. For this curve, we have here the curve is below x-axis and velocity is negative. Then we have backwards direction of motion. Okay. Acceleration is the slope of this tangent at any point moment between t1 and t2. Here, if we take this one and we draw this axis parallel to x-axis, then we have this tangent theta is acute, then acceleration is positive. Okay, we can multiply v and a. This is lead to negative signs. Then we have here decelerating motion in backwards direction. Okay, for this curve here we have v is positive as the curve is drawn above x-axis. Then we have forward motion. For the tangent here, for example, okay, the theta here is obtuse, then we have acceleration is negative as the tangent is negative. Okay, the slope of this tangent is negative and tan theta is negative as well, then acceleration is negative. If we multiply v and a, we'll find or get a negative value. Then we have here decelerating motion in forward direction. Okay, for this curve we have v here is negative as the curve is below x-axis, then we have backwards direction. Okay, for acceleration we have to find the slope of the tangent to this curve at any point relating to this open time interval t1 t2. Here we have theta is obtuse, then acceleration is negative. By multiplying v and a, we'll find positive values. Then we have here accelerating motion according to the sign of va, in backwards direction according to the sign of velocity. Okay, for this one we have here velocity is positive as the curve is above x-axis. Then we have forward direction of motion. For acceleration, we can find the slope of this curve at this point below between t1 and t1. Then we have theta here is acute, then we have acceleration is positive. Then we have here but we have here acceleration is positive. Okay, then we can multiply va. Okay, we have positive and positive value. Then we have here accelerating motion, okay, in forward direction. Okay, for this one we have the slope of the we have v is positive as the curve is above x-axis, then we have forward also. Okay, but if we find the slope of this curve theta is obtuse, then we have acceleration is negative. Okay, then va is negative value, then we have decelerating motion in forward direction. Okay, finally for these two curves, we have for this one we have here velocity is negative if the curve is below x-axis, then we have backwards direction of motion, and we have here this slope, the slope is negative, then acceleration is negative as well as theta is obtuse. Then we have here va is positive value, then we have accelerating motion direction in accelerating motion in backward direction. Okay, and for this last curve we have v is negative as the curve is below x-axis, and we have backward direction also. Okay, but here the slope of this curve is positive, then acceleration is positive. By multiplying v and a will find or get a negative value, then we have a decelerating motion in backward direction. You have to notice that if we have velocity as a function of displacement and displacement as a function of time, we can use chain rule to find dv dt as dv dt equals dv dx times dx dt. dv dt equals a, then we have dv dt dx times dx dt is velocity, then acceleration can be expressed as acceleration equals velocity times dv dt, the derivative of the velocity with respect to displacement. Okay, now it's time to try to solve a question in following vx curve. For a body moves in a straight line, identify which of the following acceleration displacement curve corresponding to the given curve. The answer is curve C, but you have identified why. Okay, we have this given curve, vx curve. Okay, which one of these four given curves is corresponding to this given one? Okay, the solution or the answer is this curve, but you have to identify or to find out how we convert this curve to this corresponding one.